Well, good morning. It's certainly a pleasure to be here, and I have to say a particular congrats to Paul and Kelly as program or as event chairs and co-chairs as well, Laura and Paula as well, for putting together what I think has been a very informative event and certainly one that's much needed. Because at this stage, we're very much awash in a world of data, and our ability to interpret and understand that world is really what the process and practice of analytics is about. So having had the opportunity of listening to the speakers yesterday and looking through the agenda about what's coming later on in the day today, I'm going to take a fairly broad overview and a fairly abstract view of what it is that learning analytics should do and the role that they really play in socio-technical sense-making processes. So very broadly, if you look at what is research and what is the research enterprise about, it's essentially a way whereby we can discover the relationships that exist between one to multiple entities. And whether we're looking at something as basic as, does bloodletting lead to better health? Or whether we're looking at something more complex, such as, what is the relationship between learner previous or existing knowledge in regard to their capacity to understand in a sequential manner new knowledge concepts. We're essentially trying to understand, is there a relationship, and if there is, what's the nature of that relationship? And what the scientific method afforded us, and what we're carrying on in the analytics tradition, is essentially a structured pathway to doing that, a set of principles that guide our activity and thereby can shape or allow others to duplicate the results that we have produced ourselves. And this is something in a recent Pearson report that they tried to articulate, that given the quantity of data, and this was discussed at length yesterday, lots of data, new approaches to getting data. The Internet of Things, no doubt, is going to be an opportunity for just a huge quantum leap in terms of analytics capturing potential. The reliance on things like beacons and other entities in physical objects are going to serve to blur the physical and virtual worlds to such a stage where I don't think in the future we will really have anything that is not either captured or capturable. And so this quantity of data, the connectedness that the data we're collecting reveals, gives us some terrific opportunities for analytics or for just being able to better understand the world, more accurately better understanding learning. And this is based really on a fundamental concept that goes back to 1972 that P.W. Anderson wrote in his paper with the same title, which is More is Different. And the general concept here is that if you have a small entity of something, you interact with it in a certain way. For example, if I'm in a classroom teaching 3 students, I don't need analytics. I don't need to really worry much about the data collection process unless I'm trying to keep a record for someone else to interact with that data in the future. But primarily, if I'm in a classroom with a small group of learners, I can interact with those learners, make sense of that process, and intervene and adapt and personalize the learning process. Now, we don't have those kinds of relationships with students today. And to a certain level, maybe going back to Lyceum and Academy and the Plato days was really the last time where we had that. Once society started moving up to large structured instruction and the creation of the university system as a whole, that relationship of one-to-one has sort of progressively become more complex. To now you may have a group of students of 200 students in a university introductory course or more, 30 students in a K-12 system, and essentially you're interacting with those students through some system where you can't capture and make sense of everything that's happening. You might have them for one class for an hour in the morning, and that's it. So you don't know what they're doing in other spaces. So we need to start thinking differently about the kinds of data that we're gathering on our learners and how we intersect with that and our learning practice. Now, in fairness, this idea of quantity isn't new. This was something that, going back to 1550, Conrad Gessner wrote that there's a confusing and harmful abundance of books. There's just too much stuff out there. So this idea of data abundance, which we think is a bit unique to our era, certainly isn't. There are illustrations of certainly, let's say, the biological classification schemes that were attempted to make the world sensible through clustering and categorization and so on, and I'll get into that in a little bit more. But the world has really faced, since really the start of time, and the ability to record knowledge into artifacts, whether those are scrolls or tablets or even cave walls. The world has faced this issue of data abundance, and we've always been chasing abundance with a series of techniques that helps us, or we think will help us, make sense of it. And so we take some methods, for example, Diderot's encyclopedia, which basically is an index of indexes, where there's a huge range of books, you can't read them you can't read everything that's going on, the amount of ideas that are being generated. So one way to do it is to take those books and just reduce it to, a book becomes a paragraph. And that's what's posted at least in the first instance of encyclopedias. Eventually, we start looking at levels of abstraction or even visualization attempts, such as classification schemes, knowledge trees that help us to look at a very difficult landscape and be able to see what is it that exists there. More recently, we've started to do this with some approaches, such as using software to help pattern those relationships, or finding different approaches to try and articulate and identify networks. So the big problem then with analytics and visualizations that we face is the issue of abundance, and that's the solution that I would argue that abundance is the problem to which our analytics and visualization approaches are intended to be a solution. And so we take a variety of approaches in order to make sense of this. So visualization essentially is just a current model of what we used to do with an index of indexes. It's a way of taking, here's this enormous amount of data, 150 million clicks of student interaction in a MOOC, for example. There's no way you can individually or cognitively apprehend the scope of that data. So in order to even start to interpret that, we build techniques and methods for clustering. We build techniques and methods for putting them together in categories that help us to understand what's there. We create analysis and evaluation techniques for us to be able to understand things that we can't do cognitively anymore. And so it's this process of aggregating and abstracting and ultimately connecting. And so on one level, the process of analytics and visualization, which I'm really using interchangeably, it's a tool to think with. It's essentially a cognitive model that enables us to contribute to the ongoing legacy of sense-making in the world. Whereas in the past, with limited data, we were able to, through books, through images, visualizations, and artifacts, stories and narratives, we were able to share with others how we saw the world or the values by which a community that we were a part of functioned. When the data itself became so significant that we couldn't engage in those processes through narrative and through even certain narrative levels of abstraction, that's when we start to rely on technical means to try and make sense of it. And so that's essentially sense-making. That's sort of a very brief intro to the issue that we face, which is a data abundance, and the way in which sense-making plays a role in the ongoing legacy of interpreting the world, and that process is now aided by technology. So I'm going to now turn and talk a little bit about the sense-making experience, what's involved in sense-making and wayfinding is a term I'll use to articulate that. And then once I've talked through that particular method or technique, I'll move into a discussion of how we make sense of information. I'll give you a couple examples of projects that I've been involved with. Then as we move along toward the end of the presentation, I'll transition into talking about what does this mean to you at various levels. What does this mean to you as an individual? What does this mean to you as, let's say, a faculty member? What does this mean to an institution? And ultimately, what does this mean to the field of education broadly? So that's sort of the pathway that I'll move through the rest of the presentation. So sense-making then, another definition would be that it's this process of labeling and categorizing, stabilizing the streaming of experience. There's so much stuff going on. It's really about trying to make sense of that, get our arms around this thing that's happening. And without going into great detail, I mean, it happens on a continual basis. There's daily sense-making that we do that might be, let's say, if you're out of town like I was, my socio-technical sense-making process for finding this venue and for finding the room is a combination of Google Maps, asking questions, chatting with folks at the front desk of the hotel. When challenges become more complex, such as we saw, let's say, in the Black Hawk shoot-down in Iraq, or what we saw with the SARS virus in early 2000, when those challenges become more complex, we start to see this interrelationship of socio-technical systems where the experience of sense-making is vital to the effective functioning of that system. So do we identify the coronavirus rapidly? Are we able to articulate what is it and how do we react to it? Or if you have a huge issue like the Bhopal disaster in India as well, those are instances of collapse of sense-making. Or the Man Gulch disaster that Carl Weick writes about, where you see the structure of people interacting with one another and things start to fall apart, and our ability to interpret interpret the data that's coming in is no longer accurate, and calamity is the end result. So sense making is a process that we're involved with, either rudimentary daily things such as where do I find my coffee, to more complex things such as there is something happening that's unfolding. It could be a natural disaster, it could be a terrorist attack, it could be any range of factors that we need to interpret, respond to, and then act in an appropriate way. Now, increasingly, these activities of sense-making are becoming participatory, and that's driven through just the technology agents. And this came up several times in the discussion yesterday. Recently in Arlington, actually on the weekend, in Arlington I was driving by, and there was about 8 or 9 fire trucks, numerous emergency vehicles off of Cooper Street. And typically, you wonder, I wonder what that is, and you just kind of go. But in this case, I pulled over and just checked Twitter, Arlington, and of course, Twitter very quickly informed me there was a fire. It was linked to other resources. So that's just an example of a simple way where individuals stabilizing their streaming of experience, making it transparent, allows someone to quickly make sense of a situation through the technology we have access to. Now, this is a participatory approach, so we're doing it through social means. And also, this is a process where I'm shifting more so that's sense making. It's how we stabilize the streaming of experience in order to make sense of the world so that we can act appropriately. Another process which is very much related to it is a navigational process. And this is something that Darkin has written about extensively, and that's the idea of wayfinding. Now, much of Darkin's work initially looked at the process of wayfinding through gaming settings. How does a gamer understand what should I do in this element, where should I move, and what should I do in this regard? And that Darkin's work in turn was initially based on an assessment and analysis of road signs on U.S. interstates that goes back to the 50s and the 60s of trying to articulate how do you guide people moving at 65 miles an hour to successfully get to where they want to go with minimal cognitive intrusion. So this is that experience where, and I'll show a diagram a little more needlessly complex, but in a few slides I'll show a diagram of the wayfinding process and how we situate ourselves within complex settings. Now, here's the issue that arises, is that the challenges around living in a fragmented world, such as we do, where part of our interaction occurs on Twitter, part of our interaction might be on Facebook, there's email exchanges, there's data that relates to our current physical location, and a range of other activities, which means that we end up with a very incoherent experience of the world. And this is very challenging for educators, something that a colleague Dan Suthers called analytically cloaked data. The data is there, but we don't really have the ability to get at it because it might be stored in log files in a way that doesn't allow us to tie multiple log files back to a single identity. It might be across varying systems that also doesn't allow us to understand exactly, is the learner that uses this Twitter ID the same learner that posted in the threaded discussion forum, and is that the same learner that has this blog over here? Quite often, they'll have different IDs or profile pages as they move across different spaces. So the big challenge educationally is starting to stitch together or weave a coherent framework of learner activity so we can understand what exactly the learner did and what that means in terms of knowing. So from Darkin's work then, the wayfinding experience of these multiple spaces is really the cognitive element of navigation. It's the ability or the means by which we think through spaces in such a way that we can guide our future activity and movement. This is roughly what that process looks like. It is the experience of us forming a cognitive map or a mental structure of the environment or the situation, what you see at the bottom of the screen. It's the process of socially negotiated movement. This is particularly true by the way, if anybody wants slides, they'll be available. So just let me know and I'll share them. I assume all the slides here will be posted online anyway. It's also the process of assessment. Am I moving in the right way? Am I not? Am I getting error signs? And this is navigation around information grounds. So this is not physical space navigation. This is the navigation process and information grounds. And this is an experience that will become more explicit as learners start to engage with a broader range of technologies. To date, we've used learning management systems to fairly strongly mediate the faculty-student relationship. Unfortunately, for a lot of learners, they build digital identities in different spaces, and they may not always want to be primary participants in a learning management system. So that's one of the opportunities, is for us to start thinking about how do learners find their way through these complex spaces? How do they select strategies? How do they determine the goals? How do they navigate these information grounds? And how do they navigate multiple information grounds? So tying these things together then, this is the relation between sense-making, wayfinding, and knowledge. So information essentially is a node. It's a piece of something. It could be, depending on various levels of abstraction, and as is generally the case, any node in a network can be a network once you blow that node out fully. But it's this experience where we try to understand connections, the sense-making experience, and the wayfinding process then is one that involves the social environmental cues to navigate that information. Now, both of these, both wayfinding and sense-making, are increasingly becoming technologically driven. And that's just the reality of abundance again. So let's move this down to something that's a little bit more practical. So that was sort of more of an abstraction where the way in which we relate to ideas, the way in which we relate to information grounds really drives our need for analytics and visualization. So what is that? What do we do when we talk analytics and visualization? And for now, you can ignore the top part of this image if you want. I just really want to focus on sort of some of the bottom elements. These are what I would say would be about the 5 key points that we're involved in when we engage in some type of sense-making or some type of learning analytics activity. So when we have a chunk of data and we want to interpret that for whatever reason, this is the model I would say. We look at everything from where we're trying to model a user, create a profile of an individual so that we can then adapt and personalize to that individual at some level. It's also the process of relationship mining. We want to understand various aspects of the learning process from the individual students and so on. And we look at modeling a knowledge domain. This is something that has been done extensively in physics, for example, where concept mapping and knowledge domain modeling has been done, and in certain other science fields as well. Also, trends analysis and prediction and personalization and adaptation, which in many ways is sort of the holy grail of the analytics process. This is the thing that we're trying to do, or the place that we're trying to get at, where we can take what used to be a one-to-one learning experience, make it feel like a one-to-one learning experience through the use of effective analysis. So put that into context then. This is part of the issue of science which we overlook, especially as the conversation sometimes goes to, we want evidence-based practice. So what happens in a university research lab or what happens in a research project is rarely directly transferable into various environmental settings or various contexts. That means that in spite of our interest for evidence, it always needs to be cashed out into a design-based setting. Meaning that if the research says that a student that interacts with data in this way, or if you give a student this book and you give them these cues for navigating the conceptual structure of the book, that may be true, but only in your lab. Once you start bringing that into a school-based setting, suddenly issues such as, the nutrition of the students plays a role. The student's socioeconomic background plays a role. The student's prior knowledge, students' hobbies and activities, and so on. So when we start talking analytics, even though you'll hear often a lot of dialogue around learning analytics allow us to do this and this and this, very important to cash that out into context, because without respect for the context, we're misapplying research. And the end result, you find out, oh, well, that didn't work. Well, of course it didn't work, because you can't take a research lab setting that's quite sanitized with a student that doesn't exist in the real world and expect to have that kind of an impact. So here's what I'm trying to get to when I talk sense making. So if you look at a granular level of insight, this is what I would say educational data mining should do for us, or what learning analytics should do for us. And this is base level analysis. This is very granular research. This might be that, if students have 2 prompts as they move through course material that have some kind of affective properties in the prompts, then that increases students' chance of completing a course by 68%. This is granular level, or it might be something like the video that the students watched. If you exceed 3 minutes and 35 seconds for an average video around new ideas that you introduce to students, you're going to see a 25% dropout rate for every 30 seconds that you exceed that length of video. Now, these are, like I said, these are very granular level activities. All you're really trying to do is get very granular types of insight. Once that we build up these granular insights through learning analytics and educational data mining, you start to get an aggregate. And this aggregate is something like, we know that there's no significant difference, and there's a website dedicated, but no significant difference between students who learn online or at a distance versus students who learn in a classroom. And that's this is where we start to look at aggregate research. That's where we can start to make broad claims, but they still really need to be cashed out based on context. But generally speaking, This is the experience. And so this is where we start to have assumptions that guide, as I mentioned earlier, these analytics outputs are guideposts. They help us think through how we ought to interact with a particular topic area. And so a learning designer can then look at the research and say, oh, okay, so if I'm doing some design activity and I'm not using visualizations, I'm heavy on text, there's no video, I can expect these kinds of dropout rates from my learners. So there's a way in which to guide practice. At the higher level, where I'm currently mostly interested, and I'll talk about this in a few slides, is the idea of application and systemic impact. And that's where, how do we take the data that we generate and that we analyze and evaluate and begin to use that to shape the structure of the university. In particular, my interest is primarily higher education, but the same holds true for K-12 sector. But how do we use that to determine our next steps or actions? So let me put it in another context. So the thesis of my career, if you will, is that if you want to understand the future of knowledge institutions, you have to understand the architecture of knowledge today. And that goes back really historically. It goes back, folks like McNeely and Wolverton and others have written about this, but it's that society's knowledge institutions develop in response to what a society does with information and knowledge. Going back to the Library of Alexandria, going to the development of the Lyceum that I mentioned earlier, going to the development of the printing press, and eventually library classification schemes and so on. So if you want to understand the future of education, it's critical you understand how knowledge is created, generated, and formed today, because the institution needs to accommodate for those knowledge development processes, or the institution becomes obsolete. Now, this is what we sometimes get when we start looking at data and analytics. And this is what, part of the thing that I find frustrating, which is why I'm targeting this sense-making experience. So often you'll see an image, let's say, in this case, this is a visualization of student participation in a threaded discussion forum. It's just simply social network analysis, and you get a sense of density and connectedness. Some social networks will also give you proximity, or give you centrality. It might give you directionality, so you know who talked to whom about what was the effect of that interaction, and so on. So these kinds of visualizations, they're perhaps interesting to look at, but in many ways they're not terribly useful, because they don't give us either an actionable insight, or they don't give us a way of shaping or changing our actions. Or in some cases they're so ambiguous that we can extract multiple lessons from the process. So I want to take you briefly through what I'll call a structured analysis of literature as an example of using analytics methods to begin to understand a domain in such a way that you can begin to act reasonably within it, namely analytics as a sense-making and a way-finding process. I'll give you two examples. One is the MOOC Research Initiative, which was a Gates-funded grant that's just wrapping up, actually about 2 weeks, that I led. And the second is a look at learning analytics literature and conference proceedings. So since about 2010, 2009? Anyway, somewhere in there, I've been involved with the Society for Learning Analytics Research. We held our first conference in 2011. We just held our fourth international conference this last month in Indianapolis. So it's basically a research community where we look at learning analytics and the way that learning analytics is deployed in educational context, whether that's K-12, higher ed, or in corporate learning settings. And so it's a structured mapping of the literature in those particular fields. And this is based on a bit of a friction point that's been occurring over the last probably decade, and I think will continue to increase, but that's this argument of the unreasonable effectiveness of data. Or more broadly, it's this argument between what's the relationship between theory, the way we've perhaps done research in the past, where we create our hypothesis, we run a series of controlled experiments, we revise the hypothesis, we validate it externally, often through peers and so on, versus a data-driven process where the data speaks to us, if you will. And one of the things that Helvey and Norvig do in this particular paper, and it literally is called The Unreasonable Effectiveness of Data, is they look at probabilistic methods for translation. So statistical modeling for translation of text. Rather than doing word-for-word translation, you essentially look at, the idea is that with enough data, you don't need method, or you don't need theory. So if you have a large enough set of data, in this case with Google, they've got billions of web pages in multiple languages. So they're really saying, statistically, if this word occurs, what's the next one that would occur? And you might know within 9, because your data set's big enough, it covers a lot of the gaps that might exist. And so this is just one example of a data-intensive view of trying to interpret or make sense of the world. So here's one example where we looked at a network of authors in the LAC conference, the LAC conference, the Learning, Analytics, and Knowledge Conference series. And in particular, we looked at the disciplines. So red is somebody in computer science, blue is education, green would be other industry. And this is just a chance to look at, how are people citing one another and what are they doing in their citations? And this is a very disturbing image for me, at least, because it means that there's a lot of clustering and very, very little cross-discipline publication, meaning that the computer scientists primarily publish with one another, folks that are involved in education primarily publish with one another. The high potential prospects are the ones where there's some degree of overlap, but even then, where there are clusters that have a computer science together with someone from education, unfortunately, that cluster is rarely connected externally in some form of citation. Another process that we engaged in then with a structured analysis was we looked at what are the fields. Now, unfortunately, these images are a little smaller, but if anybody wants the paper, it's in the ACM proceedings. But this is a way to try and give multiple representation of who is publishing what. So in this case, we're looking at what's the field or the domain. Are they in engineering? Are they in education? Are they in computer science or business fields? What fields are they in? And what is the type of research that they're doing? And then the size of the bubble really indicates how many people submitted in that area, and the color as well. So in this case, you might look at computer science. We had, in the literature, we looked at 30-some instances of validation research. And validation research is particularly important because it moves us beyond conceptualizing, where someone says, I think the world is this way. So once a knowledge field becomes sufficiently advanced, you start to see greater movement into validation research, where people start to engage or critique, or as I mentioned earlier, the process of science is a process of structured discovery. It needs to be, somebody else needs to look at that and be able to duplicate that. If they can't duplicate what you did, then something's wrong, either with your results or with their research approach. So this is just a way to communicate and to quickly, at a snapshot, to look at hundreds of papers in the Learning Analytics Conference series, and to be able to state that this number were qualitative in research, this number were quantitative. Now, another approach would be for you to go through manually and look at these hundreds of different research papers and try and understand and evaluate what exactly those results mean. But this is an instance where we abstract up so we can have a look and make sense of the landscape. This is very relevant for a research field, for example, such as learning analytics or data mining. You could look at that and say, well, that's unfortunate. We still have a lot of proposed solutions rather than empirical research coming out in the field. Is that an indication of a field that is now approaching its 5th year? Should we be more advanced in our research methods, or what do we need to do to become more complex in the analysis that we engage in? So that's just an illustration of a structured mapping of a landscape through simple techniques of bibliometric or citation analysis, but I think more critically, research methodology and parent discipline of researcher analysis, because it gives you a richer overview. Another example I'll run through very quickly is one that we did with the Bill and Melinda Gates Foundation support for MOOC research. So it was about an $840,000 project. We gave out a series of grants ranging from $10,000 to $25,000 where individuals looked at MOOCs at some level. And so we initially received 266 submissions, 37 countries. There's your top countries that were represented. We narrowed that down to a second submission level where we had 78 submissions, 15 countries, and US, Canada, UK, China are still prominent. In the end, we only funded from 4 countries. China, which was one of the top submitters early on, didn't cash out in terms of submission later on, which, again, a good analysis activity should not give you answers so much as lead you to deeper questions. And so the question then becomes, why is that? If China was number 3 for submissions in the first round, they progressively dropped. Why is that? Is it a language issue? Is it a communication issue? Is it, what are the reasons? So really, like I said, a quality visualization or a quality analysis activity should produce deeper questions. And then, of course, so our final connection then, selection of processes. These were the platforms that were selected and the countries that were represented in the total institutions. So it's just a very simple example of just, you're basically counting. It's very low-level activity. We then looked at the analysis of both research methodologies. What did the researchers do with their work. Was it a mixed methodology, qualitative or quantitative? And then we looked at what discipline did they represent. Did they come from education, engineering, computer science, and so on? And then we did a mapping of the various research publications that were most cited, as well as the paper citing them, whether they were quantitative or qualitative or so on, just to give us a quick overview of who's reading what and what's being cited in those various spaces. So, this is the take-home point on that, which is essentially visualization is a brokering entity between quantity and cognition. So when we are not able to make sense of it in a regular structured way, we need to start to rely on some visualization technique. And I'm just quickly going to bring up a Word file here. Visualization doesn't need to be images. I just want to articulate that as well. Visualization can be text because it's a brokering entity. So in this case, one of the things we did with all the papers that we submitted, we used Alchemy API and did an entity extraction process of all the papers that were submitted and created a series of clusters based on the MOOC papers. And I want to go through that in detail. It's really irrelevant. The point is that as we went through literally in the range of 300 different resources and started to see what were the data sources, what were the analysis techniques, what were the principles or the key clusters. So eventually ended up with a series of 6 key clusters related to the MOOC research, from engagement, learning success, MOOC design, characteristics, social network analysis, and so on. 5 clusters. And so these clusters then, what I'm trying to articulate is in one map, you essentially have an overview of nearly 300 individual papers. And to move through that gives you a real snapshot or pulse of the state of analytics in MOOC research specifically. Now, if you're looking for probably one of the best individuals, somebody that we had come in to do a keynote for us at our second Learning Analytics conference is Katie Borner. If you're not familiar with her work, she runs an information visualization MOOC that's certainly worth looking at. And some of her work has been centered around an atlas of science, namely trying to articulate how are scientific entities connected. And this is common. I mean, to try and articulate a field, whether it's citation analysis or something similar, it's really about trying to see what is the structure of this thing so we can get our arms around this. So for the last 10, 15 minutes or so, what I want to talk about then is, what does this mean to you? If just the simple analysis of a few instances and sample visualizations of either citation networks or concept entities that were extracted from the literature where individuals published, the question becomes, if you then are interested or are evaluating how to make sense of complexity through analytics model, what do you need to perhaps take home or think about regarding some of the concepts I threw out earlier? So again, we're talking about this in the vein of sense making and wayfinding. We're trying to rapidly be able to articulate and understand the knowledge landscape. As much as I love Google Scholar and would have loved to have had it about 10 years ago or so, for students today, it's a huge plus, but it's still extremely rudimentary. Because what I think Google Scholar should provide us is not just, here's the number of people that cited this, but it really should provide us with an overall architecture of a landscape. So if I search e-learning, it should give me a lot of the things I mentioned earlier. It should give me entity extraction of common concepts that were shared or discussed in these different papers. It should give me the citation analysis. It should give me themes and clustering and trends and so on. Right now it just gives you papers and citations, but it just reveals sort of the low-level thinking that's gone into mapping knowledge domains in even significant companies such as Google. So one of the activities that I've been turning my attention to more and more has been around this idea of a personal learner knowledge graph. And essentially, the entire education system today is structured on content. So content is the be-all and the end-all. It drives everything we do. It drives what happens at a learning design level. It drives what happens at a teaching level, the assessment practice. Everything is content-centric. And I think that's exactly the wrong view. I think in the past, we've known our content as an education system. In the future, we will primarily know our learners. And that's where we can start to actually make sense of some of the data that's generated, as well as once we've properly mapped or modeled knowledge domains. So for example, let's say I'm a student who has bumped around different college systems, and I've had some, taken some part-time jobs, I've engaged a variety of activity. Right now, when I go to the university for my first year as a student, the university knows nothing about me. I start the same as every other 20,000 students might start that year, or 10,000 students that might start that year. I'm at the same point as everyone else. And that's a huge loss because, again, our system has invested in understanding content but not invested in starting to know our learners. So much like Google has a knowledge graph that indicates concept relatability, or the semantic web, or linked data that tries to articulate the nature of connections between entities, essentially with a learner knowledge graph, it's about a clear articulation of what does a learner know and how close, or the approximate proximity that learner has to mastery within that domain. So if I have a knowledge graph that captures what I've learned, what I know, it'll be able to say, oh, you're this close to being a nurse, you're this close to being a computer science, and the role of the university then is essentially a gap-filling process where you articulate what does a student know, and what is the knowledge within that landscape, and then being able to fill those gaps. So that's the first point around what does the idea of sense-making analytics mean to you at an individual, at a learner level. A second articulation I'd like to make is what does it mean to us, let's say, as a classroom and slightly beyond level. So first of all, in every university and probably many K-12 systems, there's already a fair bit of learning analytics work going on. And that analytics often is bottom-up activity. You might be just dealing with small data. You might be looking at perhaps some language discourse data. Maybe you're using a learning management system such as Blackboard or Desire to Learn or Moodle, and you're using basic log extraction techniques, or you're getting your log files and bringing them into Tableau or whatever other system you're playing with to try and make sense of what's happening there. And this is basically small level data. This is something that you can fit on a thumb drive, or you can open up in Excel. And most educational data is actually small data. We don't have, some of the MOOCs now are getting into the range of big data, but even then we're not in the range of Google/Yahoo/Netflix style big data. As it goes up, though, and this is an individual faculty member, individual teacher in a K-12 system. As we move up, this is where you start to get that system-wide level. And while I really enjoy conferences such as this, where we can spend time talking about visualization techniques and visualization methods, I think it becomes quite critical that we transition into, or at least we begin to realize, that if you want substantive change in the use of data for learning, it has to be a top-down process. Because many of the activities, much of what we need to do for moving data across multiple databases, or for automated discovery, or for targeting automated interventions, these are activities that can't be done with a one-off teacher or even a small group of individuals engaged in a learning activity project. So that's just this example. I'm trying to articulate there's a lot of stuff going on at a grassroots level within most universities, colleges, and school systems. What needs to happen in order to really make effective use of large data sets is some kind of top-down guided approach. And recently I did a paper for the Australian government on using analytics as a way to increase the competitiveness of the higher education sector. And so one of the things that we put in the paper was this example of learning analytics maturity model, which is really just a way to start thinking about how do you begin to move from just low-level alerts or basic experimentation or A/B testing work to trying to move up to something that gets more complex, where students have access to data, student dashboards, you're moving across multiple data sets. Perhaps you're starting to incorporate elements such as quantified self, where students have the ability to bring in their data or try and make sense of those spaces, to eventually where you start to look at organizational transformation, much like Davenport argues with his analytics model, but where you move beyond us using data to assess a student, but you actually start using data as a way to change institutional practices, and ultimately where it's sector-level transformation. There's a recent McKinsey report in 2011 that looked at which fields are most likely to benefit from significant use of analytics. And there's a range of them listed. Obviously, healthcare, real estate, business, a variety of factors that are going to get a huge payout from the use of analytics. They looked at the education sector and basically said while the sector would benefit enormously from analytics, it's not a sector that does things quickly, and so it's not a high potential sector simply because of the bureaucracy or the pushback to use of analytics in education. But ultimately that's where we have to end up, because if we as a school system are able to clearly, and it's not just about reporting back on what students are doing. This gets back to this issue of sense making. It's not just saying, oh, so and so did this and that in a class, and we had 89% of our students pass this course successfully. I don't know, do you pass unsuccessfully? Anyway, 85% of the students pass this course, and that level of analytics is useful. But analytics, to become practical, has to guide institutional practices. So it has to influence and say, here's what you need to do differently. Here's how you need to change your pedagogical techniques. Here's why you need to stop building lecture halls in university. Here's how these are the students that need to be talking to these students. Through recommender systems, social network structure, being able to assess the concept development of a student after they've interacted with a piece of learning material. And if it ends up being that they did this particular activity, the end result of this activity was that they actually did worse in a follow-up assessment, that's the level of feedback that should be put directly back to the learning designers, and right now it's not. And the practices of instruction, I mean, even a conference activity, an average conference, you'll get either a 45-minute, like you do today, keynote address, or you'll get a full hour keynote address. But what tells us that that's the right format? Why aren't we doing 15-minute keynote addresses followed by small group discussion and related activity? The primary reason we don't do that is because we build rooms like this where we instantiate bad pedagogy in technical or physical entities, and so it's impossible for us to have those pedagogical interactions. So that's what I mean, where you need to move from getting the insight into building things differently, building different rooms, building different spaces. And that's where the sense-making, wayfinding literature intersects. Final point, just a couple quick projects I want to talk about that I'm involved with through the Society for Learning Analytics Research. First of all, one project that we're currently engaged in is Open Learning Analytics Architecture, which, for lack of a better word, is we're trying to create sort of the Apache of analytics, if you will, or if you're into if you're more familiar with WordPress, it's about a pluggable, extensible platform that allows individuals to engage in a variety of analytics-related work. What's most important there is that the analytics results need to be open and transparent because they have to be verified. A lot of instances where I think the corporate participation in education is critical, especially in analytics and capacity increasing. But what's also critical is that educators have the ability to test, validate the data and the results, and to be able to see, are the algorithms actually achieving what they say they're achieving. I've chatted with a fair number of analytics startups over the last several years, and the message is, this is what we're doing, these are the results we're getting, but when it's like, well, can we have a look at the data and how exactly does your algorithm work, then those doors close a little. So that's one of the reasons our interest is around open learning analytics platforms, is so that educators or researchers specifically have the ability to interact with data in a way that gives them the ability to assess and to validate what others say worked for them. Another project that was, we just had a meeting a couple of weeks ago actually at Carnegie Mellon, is the Learning Analytics Master's Program, which is creating a shareable learning analytics content. We had a group of about, I think, 18 or 19 of us that joined, and essentially our commitment is to, within ballpark a year's time, to have the full content of a master's program in learning analytics freely and publicly available, because we're expecting a growing number of universities are going to start using or start developing learning analytics talent within their school system, because that's what a lot of cases schools, universities, employers need. We want to make that learning analytics content freely available so that a school system could wholesale just say, we're doing a learning analytics master's program, here's our content. They could scrape everything off our site, or they could use it and just wrap their institutional layer and identity around it. So anyways, those are two activities that you might be randomly interested in. And finally, our next Learning Analytics Conference is just outside of New York City in 2015, March 16th to 20th. So some of you may be interested either in submitting or attending.